Greetings and welcome to the pod. My name is Mark West, and during winter, you're probably rather familiar with human snot. I am, as you can tell, I've got a cold right now. But are you familiar with whale snot? Dr. Vanessa Pirotta is. Vanessa is a marine biologist, naturalist and science communicator, and has been collecting whale snot from whale spouts using drones in order to understand whale health. She's collected viruses, bacteria and DNA from the snot in a much less invasive way than other methods. She's also run whale watching tours, swum with whales in Tonga and observed them in Antarctica. I started my chat with Vanessa by asking her, how do you get into whale snot?
No, well, absolutely. I never thought that whale snot was even a thing. And so really the reason I kind of got into what I was doing is because I'm purely passionate about these marine mammals, much like yourself and many other people. And we often look to ways of trying to help them out. And my research has always been predominantly conservation focused. And so during my PhD, I had an opportunity to go down that path, which was great. And when you do a PhD, it is such a unique time of your life because you're able to dedicate 3+ years of focusing on something that, if you're fortunate, it's something you're really passionate about. To learn more about whale health, I went down the whale snot collection path, which was whale snot, which for your listeners that don't know what it is, it's that visible plume of spray rising from a whale's nostrils, which you can actually see. And we used to think it was just water, but it's actually not. It's a mixture of health information from their lungs and contains things like bacteria and proteins and hormones, and we can collect this to provide a snapshot of whale health.
And how much snot is there compared to a human? How much do whales have?
And that's a really good question. And if you think about it, so you're an adult, you're obviously an adult man and I'm an adult woman. So our body size, or our lung capacity rather, is around 6 litres. But if we compare our lung capacity to a whale, and a humpback whale at least, they have a lung capacity of over 1,000 litres. So we're tiny little mammals compared to very large mammals. So whales can produce quite a lot of whale snot. So every time they come up to the surface of the water, they will exhale and then take in oxygen really quickly, less than a couple of seconds. And so it kind of sounds like, and it happens so quickly. And it is when that happens is that often when people see whales, and for people who've never seen a whale before, it's one of the most amazing moments to see people make that connection with the whale. And I'm fortunate to see that off Sydney, Australia, when I go out whale watching with people, and it's just great. And obviously through my research as well.
And one of the really funky parts of all this is how you collect it. Because if you think about it, go whale snot, yep, cool, that sounds really interesting. Let's get some of that. How do you get it? And you've developed some really interesting ways of doing that.
Yeah, exactly. So what we've done is I've collaborated with drone experts in industry because I've got to admit I'm not the most amazing drone flyer or pilot rather. And so what we've done is we've deliberately built purpose waterproof whale snot collecting drones. And essentially it's a quadcopter, so it has 4 propellers, and then has a yellow casing to encase all the electronics. And then on the middle of the drone, we have this little mechanism that opens and shuts a petri dish. So a petri dish is a small plastic little dish, and that's where we collect the whale snot. And it has a lid, and we can open and shut a petri dish with our drone, which is super cool. And this is important because when we want to collect whale snot, for my research specifically, we want to collect bacteria. And so we want to make sure that we're collecting the bacteria from the whale lungs and not bacteria from the air or seawater. So to get around this, we also collect samples from the air and also seawater and then compare that with our whale snot samples. But yeah, what we're essentially able to do is we're on a boat off Sydney. We're waiting for northward migrating humpback whales. And then once a whale is seen, we launch the drone from the back of the boat and it flies over to a whale's position. And we can, watching the drone at all times and also using the drone camera, see where the whales are underwater. And this is super cool. And then as a whale comes to take a breath, the drone is flown through the densest part of the whale's snot with the petri dish opening and then collecting all that gross or really cool whale snot, whatever perspective you've got. And then immediately after the lid is shut and the drone's flown back to the boat, and then Us as scientists can collect the sample and process it later back in the laboratory. And that's how you collect whale snot.
How did we used to do it? Or did we never do it?
Well, it was funny. I was speaking to a really well-known scientist over in San Francisco a few years back at a marine mammal conference, and they've said, we used to never think that collecting whale snot would be possible, or at least getting information from it. And so that was something that was really amazing for me to hear. And so when I think about how we used to collect this type of information, we used to, well, first of all, collecting whale snot has only been something happening in the last 20 plus years, even less than that. I'm being super conservative. But in the past, to collect any information from whale lungs, we relied on whales that were killed or hunted, or whales that had stranded, in which case the health is likely compromised. And early primitive forms to collect whale snot used a pole, and at the end of the pole would then have like a little sort of collection dish or device. Sometimes people would use gauze, sometimes people would use a petri dish, and then have to get really close to a whale on a boat and then hold it over their nostrils and waiting for them to sort of take a big breath. And that's how one way people would do it. And there's actually some of the ways in which people are still doing it. And the other more primitive way is using little remotely operated helicopters, which was the thing to do sort of in around 2010. A publication came out showing the use of a remotely operated helicopter, which was sort of pre the drone era. And now, since drones have come out, they're more accessible and affordable, and totally transforming the way in which we collect whale snot.
And what's it like? Is it sticky? Is it really thin? Is it black? I don't know. Like I don't know what it's like.
Yeah, that's the one. You know what? That's actually a question I get asked often, and it's a really legitimate question, because when we think about snot, sometimes it's green and slimy. People are maybe sick. The whale snot basically just looks like clear water droplets. And it's really at that level, the microscopic level that we go into, where we work out that whale snot actually holds great potential for learning more about whale health. But I'm assuming that, first of all, the whales that we're collecting samples from are what we would consider relatively healthy whales. So we're not likely to see whales that have, that kind of juicy, gross whale snot. But there are cases where whales have washed up on the beach and they've had bacterial infections or respiratory infections. In fact, the listeners might not know this, but whales can actually have pneumonia, and as a result die from it. So whales are capable of carrying nasty things, and whale snot, depending on how sick a whale is, will look quite different.
Right. And can you track individuals or different species of whales, different migrating groups of whales or anything like that? Are there any kind of signatures and you can spot particular whales?
Potentially. So what we can do is we can use the DNA to work out if it's a boy or a girl whale. But that's probably not going to answer too many questions. But what we're really using this research to do is to identify or capture a level of health information that we have currently and compare that with whale health in the future. But with the humpback whale population that I'm researching, they're recovering post-whaling. So we're now seeing such large numbers in this population, which is really good news. And if we could go, we sample a whale off Sydney in 1 year and then sample it again, the chances of us resampling and working out the same whale from whale snot is going to be really, really high and actually difficult. And when we think about it, this population has over 30,000 individuals, and, using primitive methods of identification such as photographs is often challenging to recite whale individuals. But you never know. In the future, if we're collecting more whale snot and our sampling effort increases, maybe that could be a way of working out first of all, if a whale's healthy or not, if a whale's carrying a specific marker or that can identify that it is, if we can't see the animal, which is very unlikely, what type of species it is. And, these are all the kind of exciting questions we can start to ask with this new level of A, technology, and B, ways in which we ask these questions from these large animals.
Yeah. And does it tell you much about the environment? Do they snort microplastics or things like that, or what can it tell you?
Well, look, as a scientist, I'm not going to say that no, it's definitely not an option. we have not found, or we weren't specifically looking for it, found microplastics, but the animals do live in an environment where there is a chance of encountering microplastics. And the nostrils of a whale are quite large, so there is a potential for microplastics to go down there, but it is very unlikely. You're more likely to see microplastics in the food area of the animal where there's a mouth or the esophagus, which goes down to the stomach. But we can potentially look for other indicators of ocean health through this method. So, for example, we've found, in addition to bacteria, we've found viruses, and this is the first to do so using this method to collect viruses via the use of a drone from whales. And we've published on this, which is great. So this shows us, for example, that these animals are capable of transferring at a microscopic level viruses from Antarctica all the way to areas such as Australia and then back again. And what this is really showing us is the presence of microbes at the microscopic level that these animals are capable of transmitting between different oceanic environments. And also could be used as a way of detecting changes in our ocean health over time. Because these animals, when you think about it, they are actually going from one ocean environment to the next that's extreme. So, for example, Antarctica is heavily impacted by climate change, and then they're going all the way to the Great Barrier Reef, which is also subject to climate change. So these animals can be used as these massive mobile monitors of ocean health potentially, but we're still trying to work out how to best harness that.
Yeah, that's interesting, isn't it? If the on a basic level, if the water temperature changes, then the whales might want to go somewhere else when they migrate. Is that a fair call?
Yeah, absolutely. Yeah, that is absolutely correct. And often we're seeing where whales are feeding is being dictated by where their main food source, such as Antarctic krill. This is for the humpback whale at least. Humpback whales feed on Antarctic krill, and so they might then move to certain areas where there's food for krill, and krill will obviously be dictating whale populations potentially. So if we're seeing a reduction in sea ice, we may potentially see a reduction in krill, which is bad news for growing whale populations. So in the ocean, everything is really interconnected, and when you start thinking about these things, it's just so important about the different roles that marine animals play in the ocean. And one other example is sharks. So if you remove sharks from the ocean food web, you potentially may see a collapse in other components of the food web. And we've got to think about these animals as playing massive ecosystem roles to ensure that our ocean is healthy and it keeps going, essentially.
And one of the other things that impacts whales is shipping. And you've done a lot of work early in your career looking at the impact of shipping on marine giants. Is that, people think, oh, that's like physical ships just banging into whales. But I guess it's much more than that, like sonar and disrupting their migration patterns. Is that right?
Well, the use of, if we think about ships, everyone generally just thinks of ships hitting whales. And that does happen. But now some of my research that I've gone into is looking at ships in a whole new other capacity. So when you think of a shipping channel or a shipping route, we can now think of these as marine roads. So on land, we know that when you drive on a road with your car, and the impacts it might have on the environment can vary. So, for example, you might have fuel runoff to certain parts of the terrestrial environment, and also the noise from your car might acoustically impact some animals like birds, or might see other animals move away. But in the ocean, it's quite similar. So you've also got roadkill or marine roadkill, so whales can be struck by ships, but also ships can make loud noise. And as a result, some whales might find it hard to communicate with each other. Ships might also release chemicals into the ocean, which is a bad thing. Also, there are other contributors I must point out. But ships can produce oil spills from ships is a massive risk, and that can also impact marine animals. And so the ways in which my research is trying to bring together some of these ideas or changing the way in which we think about shipping in the marine environment is a positive step forward for both whales and also the shipping industry. Because we're not really trying to pinpoint the one problem on, say, for example, the shipping industry. We need to work collectively to try and best understand these shipping impacts at multi-levels. So thinking about, for example, shipping sound, as I just previously mentioned, ships might make a lot of sound at the source where the ship is, but also sounds can persist in the ocean from ships greater than 10 kilometres plus from that very ship. So this is all changes, and acoustically the ocean environment is getting louder, and shipping noise is one contributor to how we now as scientists are definitely trying to minimise our impact on these marine animals.
There were some theories bandied around in the past that sort of really low frequency sound might have been causing whale beaching. Is that still a thing?
That's a really good question. This is a highly controversial topic as well. So there has been cases where in America, in American waters, where we've seen naval activities or marine maritime activities, and then coincidentally we've seen stranding of beaked whales in certain areas, and there's many books on this. The trying to pinpoint the cause of why this activity, if it is having an impact on marine animals, is there is evidence to suggest that it may likely be, but it is also a very tricky one to pinpoint because there are so many factors. But there's definitely evidence of whales stranding with their eardrums being damaged. And, you know, how on earth could that happen? And also, like, for example, deep diving marine mammals, beaked whales in particular, they're capable of diving really kilometres deep, and if startled, potentially by sound, their response could be to come up really quickly, and as a result, they might have, you know, you can't, if you're a scuba diver, you can't just basically come to the surface after a long dive. You have to sort of take your time going back. And these animals could potentially be at risk to the bends. And so,
Right.
yeah, there's a lot of controversy around maritime and naval activities in the ocean. And so that's just, I'm not an expert on it, but I've definitely been watching the space, and I definitely know that it is one that is very controversial. And that's why here in Australia, any sort of seismic activity that is occurring within Australian waters, that you would usually incur or make sure that there's a marine mammal observer. And that's because we, in Australia, which is great, we have a great protection of migratory species, such as whales. And we need to ensure that our activities don't impact on these animals. And one of the ways we can do that is, by using marine mammal observers to look at the impacts or potentially monitor or minimise impacts, rather, of seismic activity on whales.
I had never thought of the whales getting the bends before.
Well, yeah, I've read it. Whether I'm not an expert in it, but I have read of this happening. So, yeah, quite interesting. And when you think about it, it does make sense. If an animal comes up super quick, potentially have that happen as well.
I always found this kind of interesting that whales were mammals. We all started in the ocean, then we came out onto the land and did whatever, and whales, then they went back into the ocean. So we're kind of related to them.
That is such a good point. People often forget that whales are mammals, and that's a really big point because we share the same air, so we breathe the same air. We share the same ocean, we swim in it, and also the ocean produces over 50% of the air we breathe. So we're heavily connected to whales, and we can use these whales as sort of like a canary in the coal mine. Any changes in populations might reflect changes that we're seeing in the ocean, or that we can't see, rather.
Yeah.
That's what's so important. I've recently given a TEDx talk about this, and that's what, you know, trying to make that connection to get the average person to care about whales and to care about the ocean, and using those links that people can simply sit back and go, you know what, that's actually really true. We are kind of connected.
And so where have you been? You've been to Antarctica. You've been all the way from Antarctica to Tonga. Is this all to observe whales? I mean, this is a great way to see the world.
Yeah, well, it absolutely is. So whales, I should say, humpback whales have been my main source of, or my main focus over many years. But and as a result, I've been to Tonga to try and observe whale behaviour over there, as well as compliance with the whale watching industry, the whale swim industry, rather. And also Antarctica, I went down there as a marine mammal observer on the CSIRO investigator ship. Also recently, last year, I went to Madagascar to do some whale stock collection over there. So I've been fortunate to have gone to some of the most beautiful places just for whales.
Wow, that's amazing. Do you swim with them?
In Tonga, which there is a regulated industry, I have. And the first time I swam with a whale, it was the most amazing thing. You just sort of come up to them very quietly, and then once you see this massive thing in the water, you think that they're going to dive straight away. But if you're fortunate and you've got a really good swim and you're very quiet in the water, you're not splashing around too much, and you give the animal a lot of space, you might actually have a bit of time next to them. And it is one of the most amazing things to see just how big they are and how aware of their space. And really having this massive animal look at you with their giant eyeball is something that is special and will always stay with me.
Yeah, I've heard that they're very aware of your presence, which is probably another good reason to be using drones, because that's out of the water and much less disturbing. But yeah, I've heard they're very aware of your presence in the water.
Absolutely.
So this is another arm of your career, is that you do kind of whale watching, and you take trips with people to go whale watching?
Yeah, the official term is being a naturalist.
Right, yep.
So, I do work on a boat out of Sydney, and I take people out, up over 100 people at a time, and discuss and talk about whales, talk about their behaviour as it happens, as well as that, talking about some of these really big problems that we've just discussed about human impacts on the marine ocean and some of the problems that whales face. And this is really important for people to see a whale and make that connection. And it doesn't mean you have to swim with a whale, but just seeing a whale and knowing that they're a real thing, they're not a myth. I used to think they were a myth when I was younger. I couldn't believe how amazing they were. And now having to spend time around them, or getting to spend time, it's just so cool to see such a large animal which is capable of such a large transoceanic movement. Every year, these animals migrate from Antarctica to the warm waters of the Great Barrier Reef, and they do that every year. And this is the humpback whale population of Australia specifically I'm talking about. And so to see them each year, there's a little migration of them, but there's also this migration of us as humans to see them.
I don't have an intuitive feel for them. They're so huge, yet they eat tiny krill. They live in this vast expanse, yet somehow find each other to breed and live and all the rest of it, and then they migrate all the way from Antarctica to the Great Barrier Reef. I mean, it's not a very intuitive. I don't really have a feel for it.
Yeah, really. I think the thing is, there's kind of a disconnect, and when it makes sense. Whales aren't in our lives every day, and as an average person who works in Sydney, you go into the city, you don't ever think about a whale. And so, fortunately, my career has allowed me to really delve in deep and to think about these things on a daily basis, which has allowed me to kind of make these connections and then help inspire others through the sort of the science communication that I'm able to do. And things like a podcast like what we're doing right now is one of those ways that we can get people to think about the bigger picture.
And so what's next?
Oh, that's a good question. It's always exciting. I'm planning to do more research. I'm also doing a lot more science communication, a lot of outreach. It's really important to talk to school children about this work and to show them that they can grow up and follow their passion, and that's something I'm really passionate about. Also, making connections. So I've got a lot of networks around Australia and also internationally, and it's so good to be talking science and collaborating with different scientists with different expertise to ask questions in the ocean by using whales as the main way of harnessing their power to learn more about the ocean.
Thank you very much for listening in to this episode of the pod, and thanks very much to Dr. Vanessa Pirotta for taking the time to chat all things whales. If you'd like any more information on Vanessa's work or anything else you heard in this episode, check out our website at www.thepodpodcast.net. That's www.thepodpodcast.net. I'm going to go now and deal with this human snot. That's what you get for swimming in the ocean in the middle of winter. More on winter swimming in some future episodes. My name's Mark West. Thanks for joining me. I'll catch you next time on the pod.